So good morning, everybody, and our audience are from all part of the world, and but we will record the whole seminar so that the audience, if they are not convenient to join us online, they may visit the CIB site to revisit the video speech. Uh, Now, I'm honored to introduce today's speaker, who is Marianne Armstrong. Uh, Marianne is from the National Research Council of Canada's Climate Resilient Built Environment Initiative. It's very famous as NRCC. And Marianne is the director for Climate Resilient Built Environment Initiative. Since 2016, she has led the national research program to increase the resilience of Canada's infrastructure and buildings to climate change and extreme events, helping to shape national guidance, standards, and codes. Ms. Armstrong has built her career at the NRCC over the past 25 years with research expertise in building envelope and materials and residential energy technologies. She is a professional engineer, holds a Master of Science in Industrial Design from the University of New South Wales, Australia, and a Bachelor of Science in Mechanical Engineering from Queen's University, Canada. So Armstrong is a very experienced researcher in this field I mentioned just now. So today she is going to talk to us with the title of From Research to Impact, Increasing the Climate Resilience of Canada's Building and Infrastructure. So Marianne, please.
Right. Thank you so much, Dunping. It's a pleasure to be here, and thank you for inviting me and to have this international audience today. We will be talking, of course, about Canada, but I do hope that there are some takeaways for everyone on the call, and we can all learn from some of the work we've done here and look for opportunities to collaborate as well. So we're going to speak today about the Climate Resilient Built Environment Initiative, which I am the director at the Construction Research Centre at the National Research Council of Canada. Before we begin, though, I do want to spend a few moments to explain to you a little bit about the NRC itself, as I'm sure some of you may be familiar, but many may not. So the National Research Council of Canada is Canada's premier research organization. We belong to the government. We are, in fact, an agency of the government. We have about 4,000 different researchers spread across the country, but many of them are located here where I am today in Ottawa, Canada. There's three main objectives we have at the NRC. One is, of course, to advance scientific and technical knowledge, but we are so closely linked to the government that we also support government policy objectives. And that's where this work on climate change comes from. In 2016, the Canadian government realized that climate change was a big challenge for our country and decided to develop a strategy called the Pan-Canadian Framework on Clean Growth and Climate Change. And more recently, they developed the National Adaptation Strategy. And these are really the policy documents that underpin the work that we're doing to support Canada. And the third way we support Canada is to support business innovation. So at the NRC, we work with a lot of small and medium enterprises to help them really get from the marketplace through to application. And I'll mention a few ways that we're doing that as well as part of the climate resilience work. So at the NRC, we have two main streams of activity. One is the research side, our national laboratories, There are 12 different research centers at the NRC involved in the climate resilience work. In fact, we span 4 of them. We have our Construction Research Center, our Ocean, Coastal, and Riverine Research Center, our Automotive and Surface Transport Center, as well as our Aerospace Center, have all been involved in some aspects of climate change adaptation work. In addition to the research side, we also have what we call our Industrial Research Assistance Program, who work with the small, medium enterprises. They provide advice and support as well as funding for innovation. So let's talk about Canada. So Canada, as you're likely aware, is the 2nd largest country in the world and in a very northern location. For this reason, Canada is in fact warming at twice the global rate, if not higher, even higher in the north. So with this, we're experiencing the consequences of climate change. We're experiencing changes in our weather, and Canadians love to talk about weather, but we're learning new words for things such as atmospheric river, heat dome, derecho, which is a large wind downburst event that struck a few years ago and hit some of the most populated parts of Canada. By the end of the century, assuming a high global emission scenario, our country could see upwards of 5 degrees Celsius in temperature change, and even more drastic in the north. And it's not just one climate disaster that we're concerned about. We're concerned about many of them, all aspects of climate change. And if you look at one of the measures we have for the impacts of climate change is our natural disaster insurance payouts. So in terms of insured losses, the top 5 events, and this was only up till 2022, it hasn't been adjusted for the last couple of years, but if you notice here, the top 5 events are very different types of hazards. We have wildfire, ice storm, floods, hailstorms, windstorms, hurricane in the mix here as well. So it's not as simple as just addressing one of the disaster types. We have to look at all of them. So thankfully, as mentioned, in 2016, the government of Canada did decide that this was a large priority. So that established our first initiative called the Climate Resilient Buildings and Core Public Infrastructure Initiative. Since then, we've continued working up till this March 2026 and beyond till 2028 with additional funding in partnership with Housing, Infrastructure and Communities Canada. And currently, we're also in the process of designing the next 5 years of research as well. So still the problems exist, still the challenges are there. And we'll speak a little bit in this presentation to some of the challenges that we're experiencing as we undertake this work. So for in Canada, as mentioned, we're looking at all the weather extremes. We're looking at their impacts on different types of infrastructure and buildings, including water, wastewater, roads, urban transit, bridges, and buildings primarily. But we're looking at some of those weather extremes like wildfire, heat, wind, but also at the longer term consequences of climate change. So the impact of climate change on service life, shortened service life, aspects such as corrosion, the slow degradation of permafrost is also in concern in our northern regions in Canada. So there is a lot of work to be done. And I would be remiss if I wasn't coming here with things that have been accomplished over a decade. So I'm also pleased to say that we have accomplished quite a bit in the past decade to advance guidance documents, standards, data, technologies, and tools. And you'll find all those at the QR code on the slide if you want to learn a little bit more about any of them. A few examples presented here include some guidance related to flood risks. You see basement drainage on one side. On the other side here, you see coastal flood risk. That's based on a number of pilot studies that were done across the country. In the middle, you see our National Wildland Urban Interface Guide, which was developed about 6 years ago, and that is now advancing to standardization. And I'll explain a little bit more about that guide as we go. On the right as well, you'll see our Design Value Explorer, where we have provided access to the design data that's needed really to help design our buildings and our infrastructure for future degrees of global warming. And I'll dive into that one a little bit as well. So how do we get from science to implementation? So as researchers, we're really good at the science part. You know, we can pat ourselves on the back. We're excellent at understanding, in this case, how Canada's climate is changing, working with the climate scientists, and then understanding how it's going to impact infrastructure and what we can do about it. But once we have the science, great, we can put it in journal publications, we can present it at conferences, but we're not reaching the practitioners. The way we reach the practitioners is through bringing together experts across the country to develop guidance documents. And there's a couple shown here as examples. But even once the guidance is there, it's not necessarily applied. So we need to translate it. We need to have tools, technologies, standards available. And even then, we're still not at the point where it's being taken up and regularly implemented. I would say for many of the hazards and asset types, we've developed quite a number of tools, technologies, and standards, but it really is a challenge to get that used and implemented. And we'll speak to that at the conclusion of this presentation. So where did we start from? We started from a gap analysis. I think all good research starts from understanding what is needed. And so we had a number of researchers at the Research Council and partners undertake a gap analysis back in 2017 that looked at all these different aspects and different asset types. And this is the document that really set the stage for the research that we have been undertaking over the past decade. So I'm going to dive in some examples of the projects that we've worked on over the years and give you some insight into them as well. I'm going to start with what is probably one of our biggest successes. When we first started, both buildings and bridges in the codes were referencing data from the past 30 years, and many of them were referencing data that was as old as the 70s. So there was a need not only to start building for the climate we are seeing now, but also to understand the future climate and how we could design for it. So we partnered with the climate scientists. I like to joke, we locked the climate scientists and the engineers in a room to figure this out. But certainly it took many, many discussions. We had to start even with understanding what the definition of data was. So to set a common space, common ground. So ultimately the climate scientists, they developed a number of climate data variables for us for different degrees of global warming, right up to 3.5 degrees Celsius. This included temperature, rain, wind, snow, and ice data that all then informs the way we design and build buildings as well as bridges. One of the challenges too was getting the climate scientists to feel comfortable in sharing data that was uncertain. There is a huge amount of uncertainty in the future. We don't know exactly what the future scenario looks like. There is quite a bit of greenhouse gases already baked in, so there is a good sense of where we might be in 50 years, but it gets more and more uncertain as we get out to 75, 100 years. Different variables also carry different amounts of uncertainty, whereas temperature is quite certain, rain a little bit less so, and what we call tier 3 variables such as wind were very uncertain. But we were able to work together and convince the climate scientists that it was okay to share information as long as we knew what that uncertainty was. The engineers could then use that information to design for the future. And we also knew that using future projections was far more certain than continuing to do what we were doing, which was designing for the past. So I'm really pleased to say that not only is this information available online through that Design Value Explorer, but this past year, both the building code and the bridge code have adopted the future data. And so Canada is now able to design those assets for the climate that they're actually going to see and improving their service life as a result. Another important project that we undertook with the NRC was developing a national guideline for wildland urban interface fires. It used to be that Canada's wildfire season lasted a number of months, and then our firefighters could go help in different parts of the world. What we're seeing now is the fire season is lengthening. We're seeing we're even seeing fires lasting through the winter, sort of zombie fires lasting underground and reoccurring in the spring. We are seeing damages, including major losses in Fort McMurray, was one of our largest wildfires in Canada, as well as probably one of the larger tragedies from wildfire, which was the village of Lytton in British Columbia. In 2021, they experienced the record high temperature for Canada, on like the highest temperature on record. The following day, the entire village was destroyed by wildfire, or 90% of the village was destroyed by wildfire. And it's taken them years to rebuild. Needless to say that this is an ongoing and growing concern in our country. Back in 2026, it's actually just following the Fort McMurray fire, we brought together experts from different backgrounds, including fire experts, engineers, trying to think, we had fire safety folks as well, forestry experts, to come up with a wildland urban interface design guide. And so this guideline includes both measures that can be undertaken at the building level, but also measures that can be undertaken at the community level as well. So that was published in 2021, I believe, and I'm pleased to say it's now in the process of informing the development of 2 new national standards. And we're also undertaking policy discussions with the building code to understand the role of the building code in addressing wildfire. It won't be able to do everything. Wildfire needs to be addressed through maintenance, through landscaping, through community design as well. But there may be some pieces that can be addressed at the time of the building is constructed, such as material choice, covering openings, etc. This guideline is also heavily technical. And so we found the need to digest it into something that's more usable by communities, by builders, by homeowners. And so we worked with the Institute for Catastrophic Loss Reduction to develop a good, better, best checklist to give people options for improving the wildfire resilience of their homes. So this is a nice pathway to demonstrate just how long it takes to get from that gap analysis through to use. So even once we reach the standard publication in 2027, it still doesn't mean someone's going to use it. It still won't be in regulation unless it's chosen to be used for regulation or chosen to be used for requirements for projects. Ultimately, the soonest we may see something used readily in regulation would be 2030, and that's only if the building code undertakes this policy discussions and decides to pick up pieces from the guideline and from the standard. So from fire, I'm going to move to flooding. And I'm going to speak, even though we're developing standards and guidance on structural design of buildings for flooding, structural design for coastal regions, riverine flooding as well, I wanted to speak to something slightly different around flooding, and that is the work we're doing with industry. So green roofs, as well as blue roofs, which is another term, have the ability to retain water and let it go slowly. So this helps to mitigate the runoff from buildings and helps to mitigate stormwater flooding. So one of the challenges we had, though, was there was no standard for measuring this in Canada. So we brought together a number of industry players who had vegetative roof assemblies or more traditional water retention assemblies, and developed what you see here, which is a storm simulator. So you would have your vegetative roof, VRA, on the bottom there, and the storm simulator drops water onto the roof in a controlled manner, so we can simulate different types of storms. We can also dry out the vegetative roofing to see how it performs for different levels of moisture content and get a sense of how this assembly would perform under different situations. And with that information and with industry, we then have gone ahead and started developing a test standard for vegetative roofing. And so this standard will help inform the performance or help ensure the performance of the roof is well known and understood before it's installed. And along with that, we're developing guidance for installation of these roofs on buildings in collaboration with municipalities in Canada. Another aspect of flooding is looking at how we can protect from flooding using temporary barriers, both property level protection barriers, as well as ones that go in windows and doors. So if you look at this, this is probably the first time that the Construction Research Center and the Ocean and Coastal Research Center have collaborated so closely together. You can see we actually sent over some of our builders to build a house in their wave tank at Oakry, and all this happened here in Ottawa. And that was a project with Architectes Sans Frontières Québec, which is Architects Without Borders Quebec. We're quite keen to undertake a project with us in that space and look at the performance of different types of door blocking and window blocking barriers, and to see how they perform. On the right, we have a different type of flood barrier that we've been testing and developing test standards for. Some of the current standards really looked at evaluating flood barriers just for one situation, whereas depending on your application, you may have more steady water, you may have more of a flow in the water, you may have deeper water. So we've been developing a performance standard to assess deployable flood barriers for different levels of or depths of water as well as flows. And this then enables our product manufacturers to be properly assessed and to better understand where their barriers can be properly deployed. So from flood, we're going to talk extreme wind now. We partner under our climate resilience work with over 200 different partners across Canada, some in advisory aspect, others we work directly with, and this is one of those examples. We partner closely with the University of Western Ontario, who are definitely the wind experts in Canada and are also internationally known. These are the people who go out post-disaster, post-tornado, and look at the impacts on the building, trying to understand how we can improve our construction and where things failed. They also have one of the coolest facilities that I've ever seen in person, which is the WindE research facility at the University of Western Ontario, where they can create a full tornado in the middle of the room, as well as downburst conditions. They had a project called the Three Little Pigs project, where they had actuators that could simulate wind loads on a full house construction, so they could determine what methods work best for improving the wind resilience of our homes in Canada. So we partnered with them starting a couple of years ago to develop guidance based on all their knowledge for the retrofit of houses and small buildings for tornadoes, as well as to develop code change requests to address tornado loads. So we work in parallel with our code system, where we'll develop the research and look to inform changes to the codes. And right now we're working very closely with the task group on extreme wind for the building code. Something else we asked them to look at was whether climate change was changing the patterns of tornadoes in Canada. And unfortunately, they said there wasn't enough data in Canada to be able to look at those trends. Notionally, what we're seeing is tornadoes, at least anecdotally, we're seeing more tornadoes in Ontario than we saw before. So in this region down here, which is one of the most populated regions of our country. But there is not the data to bear that out. What we're seeing as well is, interestingly enough, in years where we have a lot of wildfire smoke, that seems to cause an attenuation of the large storms that cause tornadoes. So as we see more smoke, we may see less tornadoes. I'm not sure which I prefer, quite frankly, having seen both, thankfully not being affected too much by tornado, but certainly we've had some very high wildfire smoke years in our country. And yes, so in case you're wondering, Canada also experiences over 100 tornadoes per year in general. So moving from tornadoes to durability, and in fact, a look at extreme winds still, we do a lot of work both on roofing and wall assemblies as well. The main thing that underpins durability of buildings in Canada is a standard called CSA S478, where we work closely with a CSA group to convert what was a guideline into a standard. So that took us a few years, and more recently to divide this standard into two sections to differentiate between portions that were related to maintenance versus what could be used at construction of the building in order potentially to inform changes to regulation. On the side of roofing, we have a consortia that's been going for over a decade called SIGDERS, which is Special Interest Group on Roofing, where we have been working with industry to identify their challenges and their needs, and undertaking research projects in collaboration with them to help advance roofing in Canada and in North America. So one thing that they identified as a need was to develop requirements for climate resilient for low slope roofing systems. We work closely with them then to develop what would be almost good, better, best criteria, or I think they say bronze, silver, gold in this case, to ensure that a roof is resilient to extreme wind. And so that standard is published there, and also developed with them what's called an online tool, Climate RCA, which provides information on the climate data in different locations across our country, and also then helps you design a roof for either that good, better, or best performance that you're hoping for. So from roofing, we're going to go to overheating. Canada experienced a heat dome in British Columbia a number of years ago, and it resulted in over 800 deaths. And the majority of those deaths occurred inside buildings. So there is a challenge in how do we make sure that people are safe in their homes. I know not everyone thinks of Canada as being a warm country, but we do see upwards of 30 degrees Celsius in the summer, 35 degrees Celsius. We've seen record heat now with 40 degrees Celsius as well. And our buildings are generally built light and tight for the winter season. And we spent a number of years optimizing heat gains as well to help with heating. So it does put us in a situation where we have buildings that are not cooled, that have the potential to cause risks for the occupants. And so we've been looking at what can be done about that. We've been measuring in buildings, in community housing as well, to understand what the exposure for the people in the building looks like. We've been modeling that and then coming up with strategies such as shading, ventilation, green solutions as well that can help improve the performance of the building and mitigate that overheating condition. And the last project I'm going to leave you with before I talk a little bit about some of the things we learned along the way is our CCMC Climate Resilient Product Assessment Pilot Study. So we realized as we're putting out guidance for wildfire, guidance for flooding, that we needed to make sure that industry was also coming along. The Canadian Construction Materials Centre, which is housed here at the National Research Council, evaluates innovative products to ensure they meet the code requirements. And those are minimum requirements. Whereas the guidance we were developing on standards for wildfire, for example, goes above and beyond what's currently in our building code. So we wanted that opportunity to be able to assess products above the minimum code requirement to show that they would perform in a wildfire situation, extreme heat, hail, or extreme wind. And I'm pleased to say that the wildfire criteria has been developed for roofing, cladding, decking products and systems, and we're on track to launch that this year. And so our hope is then that would develop, ensure that we have products available on the marketplace that meet resiliency requirements, and also gives consumers, builders, the confidence that those products will perform in extremes. So that's just a sample of some of the work that we've been doing, especially around buildings. But I did want to conclude with a little bit about what did we learn along the way, because it has been a journey. We started with researchers who knew a lot about research, and certainly we've learned then what it takes to get that up and used by industry. So along our pathway to resilience, I would say, as mentioned earlier, that we've reached that tools, that code, that standard space. There's a whole suite of guidance now available, and we're still struggling to get it used and implemented. And even if there's a standard, if it's not used in regulation, it's not going to have impact. And codes can't address everything. So it's a question of how do we bring along what we call this culture of resilience in Canada. One of our challenges is the construction sector. It's highly segmented, a lot of small players. All of them speak different languages. So we're good at communicating with the engineers, with academia, just naturally as the research side of things. But a policymaker needs something in a very different language. They need to understand the cost benefit, and they need to understand what you're doing and how it aligns with where they want to go. Others, such as inspectors, they need to understand that something's going to meet a requirement. And then where in this is that incentive to go and build above what's the minimum currently? So in order to help achieve these impacts, we have to work with a whole ecosystem of players. Our small bubble on the left is where we thrive. We're good at research, generating publications. We've gotten better with guidance, tools, advancing technology. We have our National Master Specification here. We do product evaluations. But in order to get the word out, we need to partner with others, such as our provinces and territories, such as informing retrofit programs, developing pilot studies to demonstrate how these guidance works, how technologies work, developing new standards. And if we're ever going to enable that change, we need to make sure that those implementers have the information in their hands in the right way. So having requirements for professionals, having education courses and certifications, informing policy and plans, informing funding requirements, saying if you want to build this building, this location, you have to make sure that you address wildfire hazards. You have to make sure you address flooding, and we can build those requirements into requests for finance, so requirements for financing. So there's lots of different ways that we can drive this change without just looking to regulation and codes. So my final slide on lessons learned is really to summarize, how do we drive research into practice? First of all, we have to bring people along for the ride. You don't want to be in a situation where you've developed a new wildfire standard and suddenly no one has the windows that you've specified in it, and so it can't be used. So the best way to avoid that is to have the builders, have the engineers, have the architects on board, have the implementers, the municipalities, the policymakers, all part of the journey with you, helping to develop the guidance, helping to implement it at the end of the day when it's finished. The other thing is make it easy to understand. We have a whole suite of wonderful, strong, scientifically based guidance that's available, but it's written for engineers. What we need is to take that information and to create derivative publications for the different audiences, for the non-engineers, so that they know what to ask for, they can understand what measures they can take themselves, because not everyone is going to want to read a 200-page guideline. Understanding the cost benefit is also critical. We've had to undertake cost benefit analysis of applying our wildland urban interface guideline across the country. In many cases, adaptation, the cost benefit is 4-to-1. I've seen 10-to-1 upwards. One of the challenges is that the cost is not always borne by the person who is investing the extra money. So for example, as a builder, if I build a house that has hurricane ties to help prevent damage from tornadoes, that home may not be the home that ultimately is hit by a tornado, because it's highly unlikely that a single house gets hit by a tornado. But if the whole community has hurricane clips, in that case, what we start seeing is we're mitigating the impact to society as a whole. So the insurers, the finances, the government are those that are going to benefit. So one of the challenges is looking at affordability, not just as an upfront cost piece, but as, is this affordable to society as a whole? The fourth takeaway is don't wait for codes to get the information out there. You saw some of the timelines. It takes us a full decade to get from research to codes. And even that was, I consider was quite fast. And even once we publish the codes in our country, you have to wait until the provinces and territories choose to apply it, which can take an additional couple of years before we get there. So even with the climate data that we developed, that took about 12 years to finally get to implementation. And then my last thing I want to share with you is to find different ways to get the information out. Codes is not the only way, it has its limitations. But specifications for construction projects, decision-making tools that can be used easily by designers, education courses, tying requirements to funding are all examples of ways that we can affect change. So I will leave it there, but just encouraging you to build for the future and not for the past. Thank you.
Okay, thank you so much, Marianne. Thank you for your wonderful and comprehensive speech that introduced the whole initiative you are leading for Canada. And I think many countries in our sector has such or similar initiatives for the resilience. But I think the work you have been done is one of the example. So I think the many countries can learn from you and to borrow your ideas and achievements for their own country in this sector. Wonderful. Thank you so much.
Thank you.
So now I would like to open the floor for 20 minutes for questions. So anybody, if you have questions, please raise your hand.
I'd also be interested in hearing if others have something to share on work they've been doing on resilience as well.
So if Don, please.
Well, thank you. And Marianne just teed me up. Actually, I was going to ask you, Marianne, to what extent you had connected with other similar organizations around the world working in this same field.
There are points of connection, but not a lot of them, because our primarily goal has been to increase Canada's resilience.
Yeah.
That being said, with the knowledge we have, we're keen to share it as well. We've been working with the United States and others through ASCE to develop guidelines on adapting infrastructure. Work Zara was doing as well was connected on nature-based solutions. Was working with CIB with one of your, I always forget the name, but I should know. That one's a task group. Yes, I was thinking of the other ones. Yeah. So, but there's pockets, and there's also like one-on-one relationships with researchers. For example, for the wildland guideline, we had expertise from the UK on evacuation, who we worked with. But there's very much it's in pockets still, and we do travel internationally, present at conferences and share knowledge that way. But certainly there is definitely opportunities to strengthen the collaborations internationally.
Thank you.
Great. I think we can do more things within CIB for the resilience, because I'm also leading a group on resilient research, but we start to discuss about to develop a series of standards for resilience for infrastructures, but it's still under construction, under discussion. So I think many countries has the same problem, and many countries may or definitely have somebody working in this field. So I'm looking forward to discuss this issue a little bit more in Finland when you come to join the CIB board member.
I'd be happy to.
Thank you so much. And more questions from the audience?
If you allow me, Professor.
Oh, definitely. Morgis, please.
Okay. Thank you. Marina, it was a wonderful presentation. I'm very happy and I have learned a lot from your presentation. One question, you have raised a very important point of making the manuals and standards to be as small as possible so that everybody can easily understand, comprehend, and implement is an interesting point that you raised. But as far as I know, many of the standards that we are using in the infrastructure projects are very voluminous, very big, and how do you achieve in making sure that the standards and manuals are very small to the point and can be easily be referred? In fact, in the recent age of AI, for example, whatsoever the case, if you put your 500 PDFs on Notebook LM, it will point out and synthesize any of the things that you need from there. But the point that you have raised is quite interesting, and if there is any approach that you have developed to make sure that the standards are shorter but without compromising the quality, I'll be happy to hear from you. Thank you.
Thank you. I think it's not necessarily about making the guidance or the standard shorter, because I think it's valuable for the intended audience, in our case, which tends to be engineers. However, there's a lot of value in coming up with derivative publications. So like one-pagers to inform policymakers, checklists of practical measures that can be undertaken by builders. We also worked with the First Nations Building Officials Association to develop targeted guidance that was practical for some of the Indigenous communities in Canada. So my recommendation is to start with your target audience and it can be local, engage them in the conversation, find out what their needs are. The Institute for Catastrophic Loss Reduction, when they came up with the good, better, best measures for wildfire, they did it for flooding, for hail. That's in collaboration with the builders and the insurers, saying this is what we need. So it really comes down to, I wouldn't say don't make it less technical, but how do you interpret that technical information for the audience that you're trying to reach? And you can have multiple publications. I agree as well that AI is a great tool. We've just started understanding it. There's some limitations on what we're allowed to use it for at the NRC currently. But I think that's one way that's a tool that may help us digest a lot of information into something that's more usable. But it's still being explored in our case as to how and when we should use it. But my main message is to start with the audience and involve them in understanding what they need. Yeah.
Thank you.
Thank you.
Good, thank you. And Morgis, you have more questions?
No, thank you so much.
Okay. So, anybody else who would like to ask a question?
Hi,
So,
if I'm
okay, Nashim, please.
yeah, hi. I am a junior policy analyst with HICC. First of all, thank you, Marianne, for
the thanks for joining.
For that wonderful presentation. Yeah, so like I work in the climate and housing division, and right now we are looking into ways of incorporating resilience into federal requirements. So My question is, when you do research and publish research from the NCR, and this is all wonderful stuff, how often do you take affordability or market uptake into account when making recommendations for policymakers? Because that is something I struggle with when I do my research. I can find like 5 different things that would make, building structures or stuff more resilient, but I find it hard to get it by if I don't add the affordability component or the market research component. So I was just curious.
Yeah, I think there's more of a push on that now, and I would love to add an economist to my team, quite frankly, to help support. In Canada, as you'd be aware, we have a big push on affordability, saying we need to ensure that our housing is affordable. But what I find is often that conversation is only about how much it costs to build initially and not to maintain. And so part of our challenge is to get the conversation to consider the cost of the full life cycle of the building and the implications of climate change. In terms of studies, we've done a few cost benefit studies on the guidance. There's cost benefits that go into as well the codes work to informing the code changes. And we also developed recently, we were looking at retrofits of existing buildings, and we costed a lot of the measures that were associated with those. Oftentimes, it's also very difficult to get costing data that builders aren't quite readily interested in sharing. Something that I've seen that's really effective has been with our Natural Resources Canada, where they've been running workshops with builders, like design charrettes, where they start to include aspects such as low carbon and resilience to wildfire, and look at how, as a whole, you can design a building, including aspects of what would be more affordable or not. And so they've been doing some really interesting work across Canada to come up with solutions in this space. But you're right, there's not enough of it out there.
Thank you so much. That does answer quite a bit of my question.
Thank you.
Thank you, Nashin, for asking. Good questions. Okay, any more questions? If not, may I ask a question about the overheating? You mentioned about the overheating issues. I think actually in China we have the same issues. But how do you relate it to resilience? That's my question.
Okay. So I think, to me, the resilience is the resilience of the people and society and the community, and not just the building itself. And this can also be a challenge when we start talking about the cost. So the cost of a wildfire, you see, like, it's insured losses, but the cost of heat is to the health side of things. The loss of life has a cost associated with it. So it's, in terms of what we're looking at, resiliency is not just the resiliency of the building, but it's the resiliency of the people within it. So we're not just looking at the durability of things, but we're looking at those indoor environment aspects. We're looking also at the intersection between wildfire smoke and heat as well. We want to make sure that our buildings are livable. And there's been a lot of work as well that's gone into understanding here at Ottawa University with Dr. Glenn Kenny, understanding how the human body reacts to heat as well, and understanding where that critical temperature lies that we need to keep the temperature below, but also for different types of people, if they have health issues such as diabetes, or they're young children or elderly, the exposure is different. So we need to understand those aspects, then to understand how we can better design our buildings to ensure that we're keeping that indoor environment safe for them as well. So this is how we see it as resilience, because resilience, what is a building if we can't live in it? And ultimately resilience is making sure that we're adapting to that climate, so that we don't in the future need to build more and more buildings and retrofit more and more buildings because we could have been doing it right from today. Does that answer your question?
Okay, thank you. I got to the
Thank you.
point. But in this case, resilience is can be narrow. The definition of resilience can be narrow or broader.
Mhm.
You brought out very broad, coverage of the concept.
Mhm.
But in that case, it seems the issues need to be addressed are unlimited. But in your initiative, you need to prioritize the research topics or the issues that is the most important, especially for the current challenges. So then my next question is, how did you choose the topic? Because your money is something like 40 million something, right?
Mhm.
So there's so many issues you need to address.
Yes.
So how do you select these topics?
So the primarily way we go about doing that is through the gap analysis. So it's not only, so we'll set up, so I'll talk about, the first one we did was large and covered many sectors, but I'll talk about a specific one we did. So when we were looking at what was needed for the dams sector, which I didn't mention today, we did a gap analysis to understand the state of dams in Canada, the climate change impacts potentially, and came up with a suite of projects that we could potentially work on. But then we needed to find out which ones were the most important. So we partnered with Canadian Dam Association and ran workshops with their members to discuss the different topics and to refine them and come up with the top priorities moving forward. So this is generally how we approach things, is to have an advisory board or as a sounding board to help us decide which were the most important to move on.
Okay, thank you. So in this case, we have the same problem. When we get a group of experts to prioritize the research agenda, then this group of experts normally bring out what they are familiar with or what is the area they are looking for.
Mhm.
So, but in this case, in some occasions, they will miss the most important issue because there's no people paid attention to.
So
How do you solve this problem?
yeah. So over the years, we found it's sort of a matchmaking problem where through policy, we define the sandbox. So we'll say, okay, we're going to work on buildings and we're going to work on overheating. And then we collect the ideas that fit in that box and prioritize them. So it's not a fully open playing field. It's very, and you can run into this if you don't define that sandbox properly, you can end up with too many things that don't align. So it comes from clear program definition of what you're trying to achieve, but there's also value in leaving that sandbox slightly open, because then some really interesting ideas come in that you may not have thought of. So you want to, once you define the area, you also want the opportunity for people to be creative and the experts in the area to suggest projects and what is needed. And what's been nice about our program is it's not a grants and contributions program. So we keep an eye on all the projects as they progress over 5 years, and we can shape them. So we can change the scope, or we can sunset things that aren't working, or bring on board new partners, or suggest ways towards more impact. And that ability to pivot and change also helps us reach better impacts and the targets we were aiming for.
Okay, thank you.
Welcome.
Okay, any more questions from the audience? So if you have questions, please open your camera and then raise your hand. Morgis again, please. You are muted. Morgis, you are okay. Thank you. Morgis, please.
Okay. Thank you. In what specific strategies or partnership have you proven most successful in getting builders and municipal planners to actually adopt these tools and standards that you have adopted? Is there any specific strategies or proven partnership that have worked, and in getting feedbacks, a continuous feedback loop, is it been put in place?
So it is still a challenge for us. The most successful ones, we have them on board as part of the committees developing the guidance. I would say one I didn't speak to is the work on coastal resilience, where we have pilot studies with municipalities across the country that inform the guidance document. So that one they're already using in practice in those locations, and we can extend it to other places across Canada. In speaking to, say, the Wildland Urban Interface Guideline, one of the challenges is no one wants to spend more money than they need to. So where we're finding that guidance being picked up is post-disaster. In the village of Lytton that I mentioned, they actually went and started developing regulation based on the guideline, but ultimately that regulation wasn't put in place because it was sort of seen as a barrier after time to getting people back in their homes quickly. So this is one of the challenges we do face. The guideline did successfully inform criteria in Jasper for building back post-disaster. And this is where there are some municipalities that are more proactive and keen on implementing new guidance, but mainly those who have experienced the disaster. So like Durham had some high tornadoes. They were keen to implement regulations around tornadoes. Calgary has experienced hail, and so we're working on developing hail guidance. But that's not necessarily helping us be preventative in preventing future consequences of climate change. Where we've seen the most success has been through linking this guidance or standards to federal funding requirements. So if a municipality is asking to build something in a certain area, great, you need to build it in a way that meets this flooding requirement or this wildfire requirement. And I think ultimately, if I look at what's going to drive the change towards climate change adaptation, it's going to be the finance sector, because they have the most at stake in their investments in mortgages and their investments in buildings. Ultimately, they're the ones who are just now starting to understand their risks, but will benefit the most from adapting in the future. But we're still not there yet.
Okay, thank you, Marianne. I think today we got a rich number of questions, so that made the time is almost there. I would thank you so much for your presentation. I think many people will benefit from this, and many more people will benefit by viewing the video on the CIB website. It's a very well prepared and a very informative presentation. Thank you so much.
Thank you for the opportunity.
Thank you. And Don, would you like, or Era, would you like to say anything?
I would just like to reinforce what you and others have said. A superb presentation, Marianne. Thank you, with a lot of preparation time. I really appreciate your efforts.
Thank you.
Okay, Era, any more questions?
No,
Anything?
no more questions. That was great, Marianne. That was just so interesting. Thank you ever so much for your time and for sharing that knowledge with us.
So both Don and Era are from CIB General Secretariat. So thank you so much. Marianne, thank you again for your wonderful presentation. and looking forward to see you in 2 weeks.
Great. Thank you.
Thanks,
Yeah,
Marianne.
thank you.
Thank
So now I would like to end this seminar. I hope all of you enjoyed the presentation by Marianne, and you are more than welcome to join the rest of our seminars in the forthcoming weeks. Thank you, Marianne, and thank you, Dawn and Era, and thank you for Moggy's efforts to organize the whole seminar series. Thank you so much, and have a nice day.